Okay, today's topic we are going to talk about getting accurate prediction with viscoelastic flow analysis. Okay, so today's keyword will focus on the viscoelastic flow analysis, which we call VE analysis in Moldex3D software. Okay, so let's start. So I would like to have a clear explanation on the VE modules or VE modules. I divided my presentation into 4 stages. Okay, so first stage, of course, we need to understand that what is viscoelastic and why it's important to you guys. And second stage, let me have a brief introduction on our modules, Moldex3D VE flow analysis. And in the third stage, about the material, which is very important to the VE modules, we will talk about this one in the third stage. And of course, at the fourth stage, at the end stage, we will share about the application of the VE flow simulation to you guys. Okay, so let's start. Okay, so what is viscoelastic and why is important? To talk about this topic, I would like to start with basic lessons of the polymer behavior in here. Okay, I believe that a lot of audience today are experienced in the molding industry, so I believe that you are also familiar with this kind of figure. Okay, so in here, actually, this is a slide while melt flow advance. Okay, you can see that actually in here. Here is a cavity wall. Okay, cavity wall in here, and here is the flow direction. Okay, in this slide, actually, what I want to highlight. Actually, you can see in this one, okay, we only see 2 things in here. We divide this melt front into 2 sections, okay, front and back, okay. In the front section, you can see that in the front of the melt front, actually, ideally, shear stress should equal to 0 because that is free surface, no friction, okay, and the polymer is random oriented and no shear stress should happen in here. So ideally, shear stress should be here. It's like a free surface in here. So this is the first point I would like to share to you in this slide. Okay, the second point is you can see in the back, okay, in the back in here, we can see that there will be skin layer and shear layer. Why it will happen? Because heat dissipation. Because heat transfer will cause the melt will start to frozen near the boundary, right? So near the boundary, it will start to have solid. With solid and melt together, it will have friction because the flow speed is totally different. And while the speed is different, it will cause friction. Okay, so with friction means force. So have force, we will have different shear distribution.